All right, does anybody have any questions about the journal? Nope. All right, we feel good about it? All right. So if you will go to your Google Classroom, see if it's already dropped. Yes, you can use your periodic table. Under quizzes, hasn't quite, I don't know why. You may have to refresh to see it. Quiz nomenclature number 1. Huh? I'm gonna close it. And oh, y'all weren't here the other time when I messed that whole thing up. It was closing in the middle of people taking it. He's not even here to say today. All right, y'all. Speaking of 5 minutes, that's how long y'all got to take it.
What? Rose?
Yes. I have had nobody have trouble finishing it. And here is what y'all wanted on the board. All righty, it's a semester test, sorry. Okay, on the back of your pink sheet are all of the ions. And Eddie and Alejandro, that is under references for y'all until you get back into school. So these are all the different ions that the different elements can form. A lot of them you already know because they come from the representative groups, but not so much from the other ones. I've been losing my pen all day long today. Try to put it in a really good place. No, I can't find it. There it is. There it is. All right, so if you notice over here, if you kind of break them in the middle, these are my cations, which would be my positive ions. Then from here are my anions, or my negative ions. These are my transition metals that can have more than one charge. And we've talked about that before. So like chromium, sometimes it'll form a +2, other times it'll form a +3, and that has to be represented by that Roman numeral that's written in parentheses behind the element. There's a couple of transitions here in your D block, zinc, cadmium, silver, but those only can have one charge. So you will not have to use parentheses with those. Over here, we have what's called our polyatomic ions. That's when the group acts as an ion. So in other words, and you may not want to mark yours up for this because you're going to be using yours. So let's say I need phosphite. If you look at phosphite, it's PO3, and it has a -3 charge. That means that this acts together as a -3 ion. That group of 1 phosphorus and 3 oxygen acts together as one ion that has a -3 charge. One has 4 oxygens and one has 3. And there's a lot of those, like nitrate or nitrite. So you have to be real careful because this is just the difference of 1 oxygen. So if you saw this written with a -3, that's phosphate. That's not phosphorus trioxide. Phosphorus trioxide wouldn't have a charge. So we're going to be using this a lot because we are not using prefixes for ionic compounds. All right. Oh, and all of these Latin words, you see all of those? I don't even know how that changed the colors. That y'all will be tested on that Monday. Y'all will need to be able to write them and spell them correctly for those, okay?
Are you on example or without? You don't count this as notes.
Y'all don't have to worry about those. We're not using those. So you can scratch them out if you want to. That's an old way of naming things before the Roman numerals, and we're using the Roman numerals.
You really had me to
This morning, I mean, somebody came in late, I can't remember, not a little bit late, and Aaron being told that whole package had to be done by the end of class. And they like, I can't remember who it was. Anyway, they believed him until.
I would have believed
I was like, wait, what?
I would have got the work real quick.
Oh, I guess that's because that's on camera. All right. So let's move on to our notes. I'm going to make these a little bit smaller. So we are on the back of the first page. So we are now moving, and what makes it a little harder, there's one set of rules for covalent compounds, which we did. Those are the easiest. There's another set of rules for ionic compounds, and then there's another set of rules for an acids. So we're doing ionic compounds, which remember is a metal plus a non-metal. There we will not be using prefixes. Those are only for covalent compounds. In our notes at the top, at the first sheet. So when you're writing the formula, you write the cation first, the metal ion, and the non-metal anion second. We've talked about that before. Instead of the prefixes telling you what subscripts you're going to use, you have to figure out what subscripts to use. That's the difference. And the way that you figure out the subscript is you have to come up with the whole number ratio of cations to anions that'll make the charge 0. So in other words, you need your overall charge to be equal to 0. It needs to be neutral all overall. Your positives have to be equal to your negatives. And there's only one way that ionic compounds can go together. So that's why you do not need the prefixes. So you'll be using your ion sheet for your charges. And of course, some of them we know just because of where they're placed on the periodic table. But if you notice your ion sheet, it does kind of line it up nicely. If it's in group 1, it's listed here, group 2, so it matches up with your representative elements. Then you have your transitions, and then you have your polyatomics. All right, so best way to do this is just to kind of look at some. All right, so I have sodium chloride. Sodium is in group 1, so it has a +1 charge. Chloride has a -1 charge. And once again, y'all probably know that, but if not, you can look on your trusty ion sheet. Remember on this ion sheet, if you just see a negative, it's an assumed -1, or a positive is assumed +1. So in this case, my positives and negatives are equal to each other. So that means I don't need any subscripts. My formula would be NaCl. For every 1 sodium, I need 1 chloride to cancel it out. That's the ratio, 1 to 1. I feel like, what have we got going on over there?
He keeps getting around. He needs to get his life.
It says nomenclature at the top.
He's always sitting here like,
Wait.
That's him. And while you're putting all that trash back in your backpack, could you pick up that trash on the floor that I think is from your candy and throw it in there too? All right. Now that's the easy one, obviously. It's not always that easy. So let's look at some other ones. Aluminum is a +3. Oxide is a -2. So they're not equal to each other. So now I have to figure out how many atoms of aluminum am I going to use with how many atoms of oxygen so the charges will cancel out. So what's the smallest number both of those can go into? 6. All right. So let's try to get 6 on each side. So I would say my Al. And what do I need to multiply 3 by? 2. And then O for my oxide, and that needs to be multiplied by 3. So 2 times 3 is 6. 3 times -2 is -6. And that's my good formula. Huh?
why didn't you start us off with easy?
gotta
Yep.
learn the
That's
hard
what I'm
before
saying.
the
But
easy.
like the first 6 weeks, I was.
Like Miss Baker, she teaches us algebraically before we learn on the calculator.
Oh, you don't like all that stuff. You don't like the theory. You like the real stuff. I do too. I'm with you. What we have to start off, it doesn't work that way, Deja. We got to start off with theory because they think we're interested in it.
That's what I'm doing now.
So, all right. So magnesium plus 2, phosphide minus 3. Same combination. It's kind of happens a lot. So I would have Mg. What do I need? 3 P2.
Oh, so you just switch it.
You were just making them and switching them. The only time the switch, you would never write a 1. And we'll see this one right now. Calcium is a +2. Oxide is a -2. Since they're already equal, I don't need any subscript at all. So that just would be CaO. So in other words, some people get to switching and they're like, I'm going to switch this and then put Ca2O2, but that's not correct. If you end up with subscripts that are exactly the same, you need to what's that called?
Helping yourself.
Cancel them out? No, simplify.
Yeah.
You're really helping me today, Leslie. Thank you. I feel like you're thinking just that close ahead of me. It's helpful.
Yeah.
And it's helpful. All right. So if you have a transition metal, it's like a little cheat sheet. That right there tells me this is a +2. So I don't even have to look on my sheet. This Roman numeral tells me the charge of the metal in front of it. It doesn't tell me what the subscript is supposed to be. Iodide is a -1. So smallest number they both would go into, 2. So copper already is at 2. But iodide would need a subscript of what? 2. Once again, if you think that they switch, Cu would get the 1. We never write a 1. Iodine would get the 2, and we wrote that down.
So the minus signs don't really.
They really don't matter. You're just keeping them in your mind that you're going to cancel your positives with your negatives.
So they switch unless they.
Yeah, if they're equal, then just simply write it without any subscripts. Now, if you have a polyatomic ion, it doesn't make it any harder. So sulfate, if you look where your -1 charges are on your ion sheet, see that sulfate is the second to the last. It's like this. So all of this is sulfate. So it has a -2. So again, we're going to be dealing with that 6. So Al2. And then I need to put all of my sulfate in parentheses because on the outside, what subscript does it need? It needs a 3 because this is 2 times, yeah, they switched. 2 came over here, 3 came over here.
So what if there's like 2?
You would, if there was 2 minuses together,
Yeah.
then it wouldn't be an ionic compound. That would be a covalent compound, and then you would have to go back and use your prefixes.
How did you know it moved 3? Because of.
How did I know what? I'm sorry, I didn't hear you. Sulfate. How did I know it was a -2?
Oh, that's minus 2.
That's a -2. It did look like a -3. All right, y'all take a minute and try out those next few. Start with copper 2 acetate. So Alejandro and Eddie, we're going to take a minute and starting with copper 2 acetate, give you all a minute to try those out.
What charge does acetate?
Acetate is, did you find it? It's -1. It's like the 4th one down. So we have a quiz over this on Monday, not tomorrow. We won't not be adding any, we still have a little bit more to do today, but we won't be adding anything new tomorrow whenever we're here for our little short time. We may do a lesson check, but you'll have a chance to work on your practice and ask questions. Time is ticking down. We'll get ready to find out. All right, we'll start here once again. That's like a little cheat sheet that tells me it's +2. Acetate's a -1. It's kind of common, so it's up in the under your -1s, I think 4th down. So my copper is already at 2, so it doesn't need a subscript, but my acetate does, which is C2H3O2. And I have to put it in parentheses because what kind of subscript am I going to give it on the outside? 2. Perfect, perfect. +2, +2 -1. So I would have FeBr2 +1 -2 Na2S +4. Somebody said they didn't know how to read Roman numerals. That's a 4. PB, oh yeah. M4, because we needed to get this one up to 12, right? I think it's about the highest we ever do. Potassium chlorate. Okay, for the potassium. Okay, if you look, chlorate is also a -1, but it's in the second column. See, there's a bunch in that particular little group. Hypochlorite, chlorite, chlorate, perchlorate. And if you notice, they increase by 1 oxygen each time. You do not have to put the parentheses on that one because you didn't give it a subscript. Some people like to put the parentheses on a polyatomic ion every time they use it.
So anytime it's a polyatomic ion,
Only if you're going to give it a subscript. Like this one would have also been correct like this. Some people just get in the habit of every time they pull something off the polyatomic, they automatically put it in parentheses.
But it's not wrong.
But it's not wrong. It is not wrong. So here we had +2. What nitrate is -1. I always forget nitrate. So 2. That one we had to have our parentheses because we were putting a 2 on the outside.
So just if you're not putting this up.
Yeah, you don't have to, but it's not going to be wrong if you do. All right. So then we're going to flip it, and we're going to be having the formulas and writing the names. There's only one way that ionic compounds will come together, so no prefixes. We don't have to describe how many of each that we have. And we're using that IUPAC system, where if you have a transition metal that can have more than one charge, you have to designate by putting that charge in parentheses. So what that means, when you start naming, if you pull anything out of this middle box, and this isn't all the ions, but these are the most common transition ions. If you pull anything out of that metal box, you're going to have to show which one you're using by putting it with the parentheses. Because some of those have 2, some even maybe have 3 different possible charges. And then also our last syllable, if it's just a non-metal ion, is changed to "ide," which is already done nice and conveniently for you on your ion sheet. And then if it's a polyatomic ion, you use it just like it's written on here. All right, so let's look at some examples. So first one, Mgcl. Magnesium is not a transition metal, so I don't have to worry about parentheses. So I simply write magnesium. And then Cl is chloride. I don't have to say I have 2 chloride. I don't have to use a prefix because that's the only way that Mg and Cl can come together and be neutral. Same thing, Na, metal, not transition metal, so simply sodium, and then P is phosphide. They're going to end in "ide" if it's a single element. If it's a polyatomic ion, you'll use it like it's written here. And if you were struggling a little bit with figuring out the root or how to spell things, now you just have them. They're already changed for you on your sheet. If it is a transition metal, so like iron is a transition metal that comes out of that middle block, you kind of have to work backwards. So what I do is I put iron, and then I leave parentheses because I know I'm going to have to figure that out. And then N is nitride. And then you kind of have to work backwards. A nitride is -3. So which iron would I be using? And I'm only using 1 atom of it to cancel that out. +3. Now, if I have +3, -3, they cancel out. So you got to kind of work backwards on that. So for instance, let's do this one, PbO2. So lead, once again, transition metal, and it is in this box. So I'm going to do lead. Then I'll give myself parentheses. I don't have to be that big, but O is oxide. Now, an oxide is a -2. But look, I have 2 of them. So I have a total of -4. So now which lead am I going to have to use to cancel that out? 4. Do the one right above it and see what lead y'all come up with that one for. Would that also have been lead 4? No, it would have been lead what? 2. Perfect. Now, if you have a polyatomic ion, it doesn't make it any harder, it just looks longer. So here I have aluminum sulfate. So I name my aluminum. So after I get rid of my metal, I see that I have more than one element left. So that when you see you have more than one element left, then come down and find that together in your polyatomics. So I'm looking for SO4 altogether. So what would that be? Sulfate. So name your metal, and if you have more than one element left, put it together and come find it down in your polyatomic group. All right. I think we y'all got a little bit of time to work on some practice, I think. Oh, no, yeah, a few minutes. You might grab some. It starts off with covalent. Y'all might want to skip that a couple of pages on your practice and just get to your ionics. Please do some at home. That way, if you're not understanding it, you'll know, and we can work on that tomorrow when we have our 25 minutes of body time together. Just practice. Maybe a lesson check, but just practice. Nothing new. Like it's a good, that's a good nerdy chemistry joke. I like a good nerdy chemistry joke. Okay, oh, still got me frozen. Yeah, I might want to put that in. Alejandro and Eddie, they're just working on practice for a little bit. Well, I guess let me stop this recording.